Okay, so part two of the square roots where we're adding and subtracting. We're going to be adding, subtracting. We're going to be multiplying radicals in the next lesson. But part two, variables are going to be involved. In part one, if you go back to part one, no variables were involved in the radicals. So notice none of the radicals, the radicands, nor the terms had any variables involved. Okay, they were all real numbers. Before we do that, though, let's go back and review something. So recall the idea of like terms and with regards to square roots. Remember, we're only dealing with square roots. So if we had 3 square root of 7 plus 2 square root of 7, again, those are like terms because they both have the index 2, hence the square root, and the radicands are the same. So it's kind of like saying 3x plus 2x is 5x, except these are actually real numbers and not variables. So that'll be 3 squared is 7 plus 2 squared is 7. Just it acts the same way as though those were variables. You have altogether 5 square root of 7s. Okay? Now, if I had this, suppose I had 6 square root of 5x plus 2 square root of 5x. Now notice the difference now. So now we have variables. So remember, in order for these to be like terms, just like we talked about here, the indexes have to be the same. So indices have to be the same. So they're both square roots. So both of these are square roots. So the indices are both 2's. The radicands have to be the same. So notice that this is 5x and this is 5x. So those are like terms. So I can combine these. 6 square root of 5x's plus 2 square root of 5x's will give me 8 square root of 5x's. That's an x. Okay? Now, these are not like terms. 6 square root of 5 plus 2 square root of 5x. Those would not be like terms because this right here, the radicand here is 5, whereas the radicand here is 5x. Remember, the radicands must be the same. So you can't simplify this. It can be simplified. All right? Now, the other thing you got to know is this. Okay, so we know that the radicands have to be the same, and the index have to be the same. All right, but what about if I had this? So these would be like terms. Again, so these are all like terms. This would be the like term. Suppose I had 2x squared root of 5 plus 7x squared root of 5. All right, now it's a little bit different. So first of all, the square root of 5's, both terms have the square root of 5 in it, so that's a good thing. Now the x wasn't there. It will be easy for you to see that this would be 2 square root of 5 plus 7 square root of 5 would be 9 square root of 5. All right. But now I'm introducing an x, and it's not located in the radicand. So you got to think of it this way as well now. In order to combine radicals, the radicands have to be the same, and they are. But if there are variables involved in the part that's not within the radicand, then that variable has to be located in both terms. So I have 2. So it's kind of like thinking of these as being together. They're not, but these are factors. But group them together. So 2x squared of 5 and 7x squared of 5 would be 9x squared of 5. All right. Now, this would not be like terms. 2 squared of 5 plus 7x squared of 5. These are not like terms. So if you look at this part here, that's 5, that's square root of 5, whereas this part is x squared of 5. Group the x with the radical. So that's x squared of 5. So these are not like terms anymore. Okay? So you can't combine these as one. So you can't simplify this. All right? So what if you had, again, these would not be like terms. These are not like terms. If you had 2x squared square root of 5 plus 7x square root of 5. So again, group the variable and the square root together. Group the variable and the square root together, now compare them. Are they alike or not the same? They're not the same because this has an x squared, this just has an x. So these are not like terms. All right. Now let's do this. Suppose I had 7x squared root of 5 plus 2x squared root of 5 minus 3x square root of 5. So I have three terms. Now I need for you to determine if they're all alike, if some are alike. All right, so if you said they're not all alike, that's true. All these three terms are not like terms, but two of them are alike, and it's these two right here. Because this term has x squared root of 5, this term has x squared root of 5, whereas this term has an x squared. So these are the only two I can combine. So 7x squared root of 5 minus 3x squared root of 5. So how many x squared root of 5s do you have altogether? Think of it like that. How many of these x squared root of 5s do you have altogether? Well, I have 7 and a negative 3. So altogether I have 4. So 4x squared root of 5. And then I'm left with this term here. Okay? All right, so it's very important that you go back and you review like terms, not like terms. Okay? All right, now let's look at some problems. Okay, so again, the directions will say either perform the indicated operations, or it could say simplify, or it could say add, or it could say subtract. Okay? All right, number 1. We have the square root of 27x minus 2 square root of 9x plus square root of 72x. All right, now remember, in terms of review, if I had the square root of x cubed y squared, remember what we did was it would be nice if, see, this is square root, so it would be nice if all the exponents were even, and they're not. This one is, but this one's not. So remember what we did in the previous lesson was we rewrote this odd power into an even power plus an odd. So in other words, we wrote it as we asked ourselves, what's the largest even integer less than 3? And the answer was 2. So we wrote this as x squared times x, and x squared times x is x cubed times y squared. And then we circled these. We circled the ones with the even exponents. Now remember, we're only dealing with square roots here, because we now know that the square root of x squared is x, and we know that the square root of y squared is y, and we're left with the square root of x. Now again, we're assuming, in all these problems now, assume that your variables represent positive real numbers. So we're not going to worry about absolute value like we did in the previous lesson. Okay, so over here, the only things I could simplify would be 27, 9, and 72. I can't do anything with the square root of x because that exponent is 1. Okay, so 9 will go into 27, so I can rewrite this as the square root of 9 times 3 times x minus 2 square root of 9 times x. I'm going to leave 9 alone because it's a perfect square. Plus, and then 72 I can write as 36 times 2 times x. Alright, so the square root of 9 is 3, so I get 3 square root of 3x minus, here, the square root of 9 is 3, so I get minus, this is 3 now, so 2 times 3 is 6. I get minus 6 square root of x. And then over here, that's going to be square root of 36 is 6, so I get 6 square root of 2x. Alright, now notice that none of these radicals have this are alike. This radican's 3x, this is x, this is 2x, so they're all different. So you cannot combine any of them, so that's your answer. This would be your answer. Okay, number 2. You have the square root of 9b cubed minus the square root of 25b cubed plus the square root of 49b cubed. So square root of 9b cubed minus the square root of 25b cubed plus the square root of 49b cubed. Alright, so 9's a perfect square, 25's a perfect square, 49's a perfect square, so those are the good ones. I don't have to do anything like I did with 27 and 72. But b cubed, I'm going to use this idea here. I want to rewrite it so that way I can get an even exponent with this. So I'm going to get the square root of 9b squared times b. So it's the largest even number less than 3, and it's 2. And then minus the square root of 25b squared times b plus the square root of 49b squared times b. And so the square root of, now these two I'm going to circle, so the square root of 9b squared is 3b. I'm left with the square root of b minus the square root of 25b squared is 5b. I'm left with the square root of b plus, and then the square root of 49b squared is 7b, and I'm left with the square root of b. Now, remember these. Look at all these. So all these terms have a b squared of b, a b squared of b, and a b squared of b. So you just add their coefficients. 3 minus 5 is a negative 2. A negative 2 plus 7 is a positive. Negative 2, and a negative 2 plus 7 is a positive 5. So we get 5. Oops, sorry, that's something's wrong. Okay, 3. So that's a negative 2. Yeah, so 5b squared of b. Okay? All right, so that's what we get. All right, so 5b squared of b. Okay, number 3. You have the square root of 4x to the 7th plus 9x squared times the square root of x cubed minus 5x square root of x to the 5th. All right, now 4 is a perfect square. X to the 7 I can write as, remember, I'll use the largest integers as largest even number less than 7, so it'll be 6. I'm going to write this as a square root of 4 x to the 6 x plus 9x squared, and that'll be the square root of x squared times x, and then minus 5x times the square root of x to the 4th times x. So basically x to the 7th, the largest even number, less than 7 is 6, so you get x to the 6 times x is x to the 7. X cubed, the largest even number, less than 3 is 2. Remember, using even numbers because the index is 2. So you get x squared times x, and then x to the 5th, the largest even number is less than 5 is 4. So you get x to the 4 times x. Now simplifying this part right here is going to be 2x cubed square root of x plus, and then here I'm going to get 9x squared times this right here will be times x square root of x minus 5x, and this is going to be x squared times x squared square root of x. Alright, now let's simplify what we can. So this is going to be 2x cubed square root of x. Now 9x squared times x, that's 9x cubed square root of x, minus 5x times x squared is 5x cubed square root of x. So notice, all of these terms have an x cubed square root of x cubed square root of x cubed square root of x. So they're all like terms. So 2 plus 9 is 11. And then 11 minus 5 is 6. So I get 6x cubed square root of x. All right, so that's number 3. All right, number 4, you have a cubed times the square root of 9ab cubed minus square root of 25 a to the 7th b cubed plus the square root of 16 a to the 7th b cubed. Okay, so let's try and simplify these square roots. So that's going to be a cubed. I'm going to rewrite this so that way I get 9a, and then remember b cubed. So you want to rewrite the variables with the odd exponents, because since the index is even, since x is 2, you want to use an even number. So it'll be b squared times b is b cubed minus, and then over here, they're both odd, so I'm going to get 25 a to the 6 times a, b to the 2nd power times b, plus the square root of 16 a to the 6 times a, b squared times b. Alright, so a to the 6 times a is a to the 7, b squared times b is b cubed. And now I'm going to circle the ones I can simplify real easily. So the square root of 9 is 3, the square root of b squared is b, square root of 25 is 5, square root of a to the 6 is a cubed, square root of b squared is b, square root of 16 is 4, square root of a to the 6 is a cubed, square root of b squared is b. Alright, so I get a cubed times 3 times b times the square root of, and you're left with ab. Okay, minus square root of 25 is 5, square root of a to the 6 is a to the 3rd power, 6 divided by 2 is 3, 2 divided by 2 is 1, so b to the 1st times the square root of ab, plus square root of 16 is 4, square root of a to the 6 is a cubed, square root of b squared is b, and you're left with the square root of ab. Alright, now let's simplify this. I can go ahead and rewrite this with the 3 in front, so that's going to be 3a cubed b square root of ab minus 5a cubed b square root of ab plus 4a cubed b square root of ab. And again, notice that all of these terms are like terms because they all have a cubed b square root of ab, a cubed b square root of ab, a cubed b square root of ab. And so all you do is look at the coefficients. 3 of them minus 5 is a negative 2. A negative 2 and a positive 4 is a positive 2. So I'm left with 2a cubed b square root of ab. All right. And then number 5, you have 5y square root of 8y plus 2 square root of 50y cubed. Okay, so the 8 I can write as, 8's not a perfect square, but I can write as 4 times 2, so I'm going to get 5y square root of 4 times 2 times y. 8y is 4 times 2 times y. Plus, and then 50, I can write as 55 times 2, and then y cubed is y squared times y. And I'm going to circle the ones I can simplify. And circle the ones I can simplify. And let's see what we get. We get 5y times this square root of 4, which is 2, and you're left with square root of 2y, plus 2 times the square root of 25 is 5, and the square root of y squared is y, and you're left with 2y. Simplifying this, 5y times 2 is 10y, square root of 2y, plus 2 times 5 times y is 10y again, square root of 2y. So notice I have, these are like terms because they both have y square root of 2y, y square root of 2y, 10 of them, plus another 10 of them is 20. So I get 20y square root of 2y. Okay? Alright, so that should help you with that portion of My Math Lab. So that takes care of part 2.